So it's important to talk about how do we take the traditional aspects of epoxy-anhydride curing technology and now shift it over to basically what the customer or what the market has been asking us for. This technology has been known for certain types of curing temperatures, certain types of curing speeds, relegated to certain types of formulations, and now we're being asked to do a lot more things that we haven't looked at before. So let's talk about cure temperature, for example.
Yeah.
What have you seen in terms of customer demand?
Right, we've seen demands for less than 100 degrees C for at least the liquid anhydride.
Which is incredibly challenging.
Liquid anhydride, monoanhydride, and epoxy systems. An example actually is pressure vessels where they have a liner based on plastic, like a high-density polyethylene, for example, and you're overwrapping with the carbon fiber, wet with epoxy anhydride, and they can't heat that liner to any higher, and they want to use a plastic liner because of weight reduction for the automotive. You know the story. So we had challenges there, and with the right catalyst technology and with the right formulation of the epoxy resin and anhydride curative, we were able to demonstrate cure well below 100 C, actually down to 80 Celsius
which is shocking.
And that's where the challenge then comes in with the use of dianhydrides, which are historically known as high temperature thermal curatives, 150 C and above. And we're seeing the same challenges as people say, well, we like the property of the finished product, but we can't cure at that temperature. And so we've done some work and we've seen some evidence that with the right catalyst, right accelerator, you can get down under 100 degrees, which to me, when we first started the process, I didn't think would be possible.
In fact, one of the things we tend to forget as raw material producers, we want our systems to be cured completely.
Exactly.
Whereas in some applications, is the level of functional cure
that
is
enough.
needed that if the customers or applications are limited to a certain cure temperature, let's at least see what level of cure you get to that, and maybe that is all they need. And we can formulate according to that, and that's what we ended up doing with the plastic liner pressure vessel technology, because
it may not have been 100%, but it gave them the properties they needed.
But there is also a structural reason why you want to lower and that is to minimize residual stresses from the delta between the cure temperature and use temperature, and from that point of view also. And as the market is now moving towards things like autoclave cure systems as in terms of prepregs, and that avoids the use of expensive autoclave cures, and they can cure it in an oven at ambient conditions or near ambient conditions.
Let's talk about prepreg. I mean, that's a good example because now we're being asked to really step up with a number of different challenges, not only cure temperature, but how about cure speed? Now we need rapid turnaround of parts, shorter cycle times. We've got shelf life issues with the prepreg. We've got different types of carbon or glass fibers that are used in the prepreg. Instead of talking about potting compounds, we're going into a totally different realm here, but a realm that is worthy of this type of technology. And what we're starting to see is brushing right up against that.
Snap cure.
Really,
exactly.
that's what's being asked. And it can apply to bulk molding compounds, sheet molding compounds.
Everything.
And the other thing that's nice about this technology is, especially if maybe it's slightly thicker or a part with more mass, I mean, there's very nice ability to provide a gentle exotherm in those systems too. So you may be doing some type of compression molded system, but all of a sudden epoxy anhydride chemistry is actually perfect for that.
And you make a very valid point, because the cure enthalpies are generally a little lower as compared to
you're able to build up thicker parts without fear of
exotherm
degradation. Another want to come back to something you said. Actually, you made a great point about expensive equipment like autoclaves being limited, and the same token, sometimes the tool, the mold is the expensive part, and then and sometimes, let's say you do need full cure. Functional cure is not good enough. You do need a full cure, but you can have the initial cure at a lower temperature for whatever limitation the tool has, for example, and then you can take the part out. It's got its structural strength, and now you can heat it up further for the two-stage cure.
Freestanding.
So there are all kinds of process and formulation tools available, tricks available
not thought about.
that we can guide our customer base into to maximize the advantages of these technologies.
Out of autoclave is very important, and even just from other assets that the customer may have. I mean, you go to a customer and say, oh, here's a 2-hour, 220-degree cure system, and they say, well, my oven only goes up to 140. I can't even use this. So now we can say, wait a second, what do you have? And we can design something that matches your assets, so you're not investing in ridiculous equipment in order to convert over to this type of technology.